Hi, welcome to this Open Security Summit session in September 2022. And we're continuing with a theme that is really taking on, which is how do we really automate and scale security? And in this session, we're going to be focusing on the permission models as code, which is one of the things I feel that is super critical. So we can control our identities and we can really control who has access to who. So over to you.
Hey, Open Security Summit. Thank you for having us. My name is Oded, and I'm the first developer of Permit. And together with Raz, our senior DevOps developer, we are going to talk about permission models as code and how to secure the entire stack with it. My background with permissions go a long way back. I worked on permission in various ways for more than 10 years. I worked about 5 years at my service in the intelligence unit in the Army. And after that, another 5 years at a unicorn startup called Clarity. And I developed the permissions there 3 times from the start. And I want to share with you some of the things that we learned along the way, and also we are doing here at Permit. So the agenda today will be, first of all, let's understand the problem, why getting permission right is so hard. After that, we will talk about permissions models, and we will explain the differences between the common models and when we need to use each model. And after that, we will see how to enforce those models with great tools that are open source, which is OPA, OPAL, and using the Rego language, and also some auto-generated Rego stuff. It's going to be cool. And after this, Raz is going to show you how to deep down and use those great tools for all the stack, from the Kubernetes level to the application layer. And of course, there will be a demo. So let's start. So let's start by reviewing the problem. Why is building permission in the right way is so hard? So first of all, there is the infrastructure that in the last years, the infrastructure has developed a lot, and we are seeing more and more services and application moving toward microservices architecture. And when we have a lot of microservices that's talking with each other, we will need to have the proper permission for each microservice. For example, we don't want a simple API microservice to get access to all the database and to manage the Kubernetes, for example. And from the other end, we don't want the database microservice to be able to reach to the internet. So we need to have the proper permission to each microservice. And it is not only our microservices, there are also third-party microservices. For example, if we are talking with API of another product, we want to be able to talk with that third-party microservice with the right permission. And when he reached to us and asked for data, we also want to give that third-party microservice the right permission. Apart from that, we also have a lot of different edge devices. For example, IoT devices, smartphones, tablets, and more. And in some cases, we want to give different permissions to each device. For example, in my stock application, I can't do some actions in my phone, only on the computer. So there is an infrastructure complexity. But not only the infrastructure become more complex, we also have the policy and the permission itself more complex and evolving all the time. We have a lot of models of permissions, and we are going to talk about it in the next slides. But let's mention some of them here. We have RBAC, REBAC, ABAC, and a lot of the times while the application evolve, we start from one type of policy model, and we move on to a more advanced model. And as I said, we will talk about it in a few minutes. Another thing that is getting more complex is that we have many data sources for the policy itself. For example, if we want to give specific features only to paying users, so we need to get that data of who is a paying user. And most of the time, we will not have this data in our database. It will be stored in a third-party company, for example, Stripe. So we will need to reach out to Stripe to understand our policy. If this user, this specific user, is a paying user, and therefore his policy is a specific policy, or if he is not a paying user, so his policy will be different. So the policy is more complex. And also we have complex rules. For example, we want different policy for working hours and different policy for non-working hours. Or we want a policy based on location. For US customers, the policy is going to be this. And for Europe users, which need GDPR, we want different policy. So the policy itself is more complex. And last but not least, the security and compliance. Each bug or error in a policy can be really, really harmful for the entire company. Of course, in the auditing, we can lose our audit if the policy isn't right. But most important, we can even lose and harm the privacy of our customers. So we can't do any mistakes in the policy. But if we will want to double check everything, it may hit our performance. So to sum it up, we have more complex infrastructure, more complex policy to enforce, and we can't do any mistakes over there because it will hurt our security. And if we will want to double and triple check everything, it will harm our performance. So what can we do? So first of all, it is a very good thing to be aware of the common permissions model and understand which of them is the most fitting to our stage of the application and our type of the application. And after that, there are also some best practices that we can use to help us write permissions in this complex arena that we have today. So the first model is really a really simple model for admin and non-admin type of user. And you all must have seen such a permission model. You can see it in the flowchart. The user log in. If he is admin, he can reach all he has access to everything. And if he's not an admin, so privileges are restricted. In each site that you have seen with an admin panel, there is a similar model in action. All the users just can see the site, and only the admin can enter the admin panel and edit the site data. Another more advanced model that is more commonly used is RBAC, which is role-based access control. And with this model, you can define roles. And for each role, you need to define the actions that he can perform on that on specific resource. For example, we have the admin over here, and we can see that admin can view, upload, and delete an image, but a viewer can only view an image and read a document. And we can see it as well in that flowchart. A viewer on resource image, if he's trying to view, he gets allowed, and if not, he gets restricted. So this is RBAC model, which is more dynamic, of course, from the admin, non-admin model. And a lot of companies start with an admin, non-admin model. And after a while, they see that they need more flexibility, and they move to RBAC. But also in RBAC, we have the difficulty. Also in RBAC, we have the difficulty of when we want to add new roles, and when we want to add more resources, it's sometimes getting hard. And also when we want to have relationship between objects. For example, I want the viewer to view all the images, but if it's an image that belongs to him, he should be able to delete it as well. This is harder in RBAC model, and let's see a model that supports that as well. So we have here the RBAC, which is relationship-based access control. And this permission model is actually a graph with nodes and relationships between them. In this example, we can see we have 3 users in the blue. The user Bob, Alice, and John Doe. The user Bob is the admin of this organization, which is the parent of the folder sales, which is the parent of the file of this presentation file. The user Bob is also the owner of this presentation file. So he has access to this file from 2 relationships. Also, the user Alice has access to this file because she's the owner of the folder sales, which is the parent of this file. But the John Doe user doesn't have any relationship to those organization folder or file, so he will not get access to this file. This permission model is really, really good when you want to use things that relate to each other. And for example, Google uses it for its Google Drive application. But the RBAC permission model isn't so good when you want to have more complex roles. For example, if I want the user Alice to be able to reach this file only in specific hours of the day, it will be really, really hard to manage that in a RBAC model. So we have the ABAC. The ABAC is attribute-based access control. And in this model, you can give permission for each attribute of a resource. For example, I can give permissions only to user according to their age, their name, their last login. For example, I want I want that every user that hasn't logged in into my system in the last 2 weeks to not get access to sensitive data. So I can do it easily with ABAC. And also at the left, you can see a Rego code that implements an ABAC model, and we will deep dive into it a bit later. Also, I attached here a link to article of ABAC Explained, which is really cool for those of you who will want to deep dive later. I will share this presentation, of course, after that. So, so let's do a quick recap. We have admin not admin, which is the most basic solution for those of you who don't want to invest at permissions at all, just to have something in place. After that, we have RBAC, which is a bit more complex and much more commonly used, but still it has some black spots. For example, the relationships and more dynamic permissions. And for the more advanced use cases, we have the RBAC and the ABAC. Of course, there is not a silver bullet solution. Many of the times, companies will start with one of those, and after a while, they will combine with the RBAC a little bit of RBAC to have some kind of relationship, or some kind of ABAC to add a more dynamic form to their RBAC. Okay, so we know now about permissions models, and we now need to manage it in a way that will help us track it and understand the policy in every single time. And we don't need to invent the wheel when we are doing that. Because as a developers, we know that we have a really good ways to manage our code. So why not write this policy as code? If we will do that, we will get a lot of good things that we will have when we manage our code. For example, we can have CI/CD process for our policy as well. We will have tracking who did this change and why. We can even test the new policy and make sure we don't accidentally give everyone permission to a sensitive resource. Excuse me. And in the said scenario that a bad permission model was rolled out to staging, or even worse, to production, we can do quick rollback. So it will be really good for us to manage our policy as code, and we will gonna show you great tools how to do it in a minute. So one really good tool for that called OPA, which is Open Policy Agent. OPA is really fast decision maker that gets data that it is policy related. For example, the list of users, the list of paying users, resources that related to those users, and also the policy, which is written in a language called Rego, which is really fast. And you can see example of it here, and we will deep dive into it in a few minutes. And then any service can query the Open Policy Agent with policy questions and get immediate answer to whether the policy was allowed or it was rejected. OPA also supports sending a list of objects that has permission, that the user has permission to access. And this tool is really battle tested. Companies like Pinterest uses it, and also Netflix. So it uses in a scale, and it's really, really battle tested. But to use it, we need to know Rego. Until Raz will show us his magic. But let's learn to read a bit of Rego. So in this file, we can see two parts. The first part is the user is the data, and the second part is the policy that it is written in Rego. The data, as you can see, we have two users and the roles. Alice, which is in engineering and web dev, and Bob, which is in the role of HR. And we also know what the permission for each role. Engineering can read prod server, web dev can also write to prod server, and HR can read the salary database. And now let's see what the policy in Rego. So the policy is allow false. First of all, you get denied if you need to have specific attributes to get approved. So we are looking up the list of roles for this user. We get the user in the input query to OPA, and we get the list of roles in these parameters. After that, for each role in that list, we are taking the permissions of this role. For example, Alice will have the action, the permissions for engineering and also for web dev, and Bob will get only this permission object. And after that, we are checking that the input action, the wanted action on the wanted object is equal to one of the permission. So for example, if Bob wants to read SalaryDB, it will be approved. But if we want to write to SalaryDB, the action here is not equals to this action, and therefore he will get the default which is allow false. So let's go back to our presentation. So we can now, and I hope, understand a bit of Rego. And now let's add the missing piece. So we have OPA, which can evaluate policy really, really fast. We know a bit of Rego now, which we can write any policy we want in OPA. And now we need the real time, because as we said in the previous example, if we want to approve paying users, we need to be able to get real-time update when a new user start to pay for our application. So for that, we have OPA, which is an open policy administration layer, and it is working with OPA that we just talked before. And OPA helps OPA to be real-time and also to have the benefits of GitOps, which is the managing our policy as code, as we talked before. So Opal has two parts: the Opal server over here and the Opal client over here. The Opal server is in charge of keeping the policy up to date. He can track a policy server or a Git repository that contains a policy, and it can send polling request or get updated by a webhook, and for each change, he will send live updates via WebSocket to the Opal client, which in turn updates the Open Policy Agent. So the Open Policy Agent will going to have the updated policy on all times because of the Opal server. Great. So we have real-time policy updates, and this is great. But we also need real-time data updates, because if we are going to have a new paying user, it's going to be a new paying user data and not a new policy change. So Opal clients handle that part for us, and he can query a lot of different resources, for example, Stripe, and for each change, it gets triggered, and it can stream the new data into the Open Policy Agent. Right now, the Open Policy Agent will have the updated policy from the Opal server and the updated data from the Opal client, and he can authorize queries from your application in no time, really fast, really secure, really great. The only tough part in this is going to be writing your policy as Rego, and Raz is going to show you some great ways how to manage this Rego creation with a great UI, and also how you apply those permissions across all of the stack.
So, hey all. First of all, I want to thank Oded for covering all the important things about permission, about policy as code, and of course, all the tools that I think they are great. And I will now show you guys how to actually use these tools. We will start from the bottom, from the infrastructure layer. So we will talk about how we actually can create admission controllers, create admission webhooks in Kubernetes. We will touch it in a minute. And then we will climb up the stack, and we will talk about how we can actually integrate policy as code as part of our authorization layer in our application. We will start with the infrastructure, as we talked about. I don't know if you guys are familiar with the Kubernetes admission controller, but now we will dive in that. So this is Kubernetes cluster services. So when we create a new request to our Kubernetes cluster, it will process to many services. So let's take an example of a pod. We want to create a pod to our Kubernetes cluster. So eventually we want it to be stored in our Kubernetes DB, which is the etcd, right at the end. So we will create the pod, and it will get to the API handler. After this, the authorization and the authentication layer of Kubernetes will give us the green light, of course, if we are authorized to actually create a pod. And after that, we will get to the mutating admission controller. And in general, we will get to the admission controller flow. So let's say we want this pod to be allowed. We want to create this pod. Why? Because we want every pod with the label gatekeeper to be allowed in this server, in this Kubernetes cluster. So as you can see in the example, I want to allow this. It's good. But if we will take this example, this pod, which doesn't have the label gatekeeper, I want to deny it. I don't want my Kubernetes cluster to have pods without gatekeeper label. In order to do this, we have many options, and we need to choose whether to use mutating webhook or validating webhook, and we can also choose both. We can use actually both, and I will show how in a minute. And the way that we can do it is using the project we'll call Gatekeeper. So let's dive into the admission controller flow. So I just zoomed my diagram. And for example, let's say we want this, as our previous example, this pod to be denied. But before we deny it, we actually want to add to this pod the label that we want. So we can actually use the mutate webhook to actually add the label. So as you can see, we have the same label that we had before, but now I'm adding it, the label Gatekeeper. When we are proceeding in the flow, we will get to the validating admission controller, which will now validate if our pod will fit our needs. So yeah, it will fit because we have the label now. So when we are talking about webhooks, as I mentioned, we have many options to actually build them and develop them. And one of the greatest options we have is to use Gatekeeper. Gatekeeper is a project which also developed by OPA, Open Policy Agent. And what it does, it basically gives us an option to create webhooks, admission webhooks, using policy. So we can use actually policy as code. We can use Rego, as Oded showed us in the previous slides, to constrain our Kubernetes cluster resources. So we will have two different objects that we will see how to create them. One of them is the constraint template, and one of them is the constraint. We will imagine that the constraint template is kind of a callback function. So like in most of the programming languages, a function needs three important stuff. So it needs a name, it will need parameters, and also it will have a logic inside it. So when we are diving deeper into the constraint template resource, we have these three attributes that we talked about. We have the name, which is the kind. So this will be the kind of the function, the name of the function. We have the parameters, which are set as an OpenAPI version 3 schema. In this example, we chose the parameter to be called labels, and it will be in type of array of strings. And of course, after that, we will set the Rego part, the logic of the template. So here in this template, we will check if our provided labels are fit to the required. So if it doesn't fit, we will deny this pod and this resource. And if it fits, we will allow this resource. So this is the constraint template. And of course, every function needed to be called somehow. So now we will actually create the constraint, the call for the function. So creating the constraint will be, we will use the name of the template that we just made, which is Kubernetes required labels. We will choose which kind, which resources we want to hook. So every webhook need to specify which resources he wants to choose. So in this example, we choose to actually hook all the namespaces in the Kubernetes cluster. And after that, we will choose the parameter. So as I'm reminding you guys that I set the parameter to be labels. And it's supposed to be a list of strings. So I set the labels to Gatekeeper. It's pretty similar to the example that I showed before, but now we are checking for namespace. So now we have a namespace with the label Gatekeeper. And of course, now the webhook will allow this. Great. So we covered the things with how to actually create policy as code flows with our Kubernetes cluster, with the infrastructure. And now we will climb up the stack and we will talk about how to create policy as code as part of our authorization. And for many users, creating and actually writing Rego can be a tough mission. So I chose to to create the Rego using the permit.io policy editor. So we have a couple of things that we need to do before the Rego will be auto-generated for us. We need to define the policy, and then we need to assign the role to the user, and then we will see the Rego that will be generated. So let's start. First, I want to create a resource. So in this example, I chose to create the Git repo resource. After that, I'm giving it some actions. So I can pull a Git repo, I can push one, clone one, or delete one. After this, we can see the table here. It's kind of nice. We have the admin role that can pull, clone, push, and delete. But we want to have another role. So I'm creating a new role called the contributor, which will be the Git repo contributors role. And I chose it to be able to pull, clone, and push. But you need to notice that I unchecked the delete box. I don't want the contributor to be able to delete the repo. So it's very important. After defining the policy, now we actually need to assign the policy to a role. We need to assign the role to a user. So I will create a user called Raz, that's my name, and I will assign me the contributor role. And that's kind of it. Now we have the generated Rego that I will show now. It's kind of similar to what we saw in the earlier slides, so I won't deep dive into it, but basically it's pretty simple. We have two roles that I created, admin and contributor. Both of them have some actions. The admin has the pull, clone, push, and delete. Of course, it has the permissions on the Git repo object. And the contributor has kind of the same, but again, it doesn't have the delete action. And also we have the user that I created, which has the role contributor. Again, as we saw in the earlier, now we are checking if I have the permission to do what I want or not. So this was the auto-generated Rego that we got from the policy editor. And actually now we want to see how we can integrate this into our application. So you can do it yourself, and I will show you a demo for it. So I created a role that called contributor, like in the example, and let's mark these actions that I want this role to have. Now I will set up a new application. I chose to write it in Node.js, but it doesn't matter. We have many other options. And this will be the code that actually checks if I have the permission to do something or not. So I copied this example, and I'm running it on a localhost environment. Yeah. Okay. So one thing that I forgot to mention is that I need to run a Docker, which is the PDP. The PDP is the policy decision point, which actually caches the data. So it helps us to isolate and actually be hybrid, and not to be depends on the cloud. We can run it on our local environment. So we are running this, and also we are not running the code. And now we want to check if I can push. So yeah, now I got the message that I'm the user, Raz Cohen, is permitted to push to the Git repo, which is great. And let's see if I can delete. And of course, I cannot delete. I'm not permitted to delete the Git repo. So let's say we want now the contributors to have access to actually delete the repo. So I will change it. I will check the delete box and I will save the changes. And now if I will refresh it, I can see that I can delete the Git repo. So this is an immediate update. As soon as I check the box and I save the change, the permission will be updated. No need to log out and log in or anything like that. So that was covering all the application layer. And as I show you guys, also the Kubernetes layer, the infrastructure layer. So I want to invite you guys to ask us some questions. You can do it on Twitter. You can do it also in Slack. We have a community that we will answer your question very, very fast. And you can also just schedule a Zoom with us with the link down there. So if you guys have any questions, we are here to answer.
Yeah, I had a couple, if I can. But this is great, right? For me, and you know, this is how we can scale permission management. Have you done a mapping on the risks that exist when you don't do this, and in a way the exploits and the vulnerabilities that are created when you don't manage permissions like this?
So first of all, when you don't manage permission like this, the ability to expand your permission is a bit limited. If you have a new object in the system, it will be harder for you to integrate that into the permission as well. So you might encounter some risks over there with like floating objects that will be restricted, or even worse, allowed to non-relevant roles. But I think that the most important thing when you manage your permission like this is the ability to actually track everything and being able to detect issues in your policy as part of your CI/CD cycle. If you are not doing this, you are prone to errors. You can send to production a bad permission policy. And if you will use all the best practices that we just showed you and have Git tracking for the entire policy, have each change tracked and commented what was the change, what was the reason for it, and the ability to test it before you roll it to production and to roll it back if there was any issues. This is, I think, the main security advantage. Of course, there are also some attacks like new enemy attacks that you can read about. I don't want to dive too deeply into that, but there is also known attacks that we prevent with this model.
Yeah, and look, I'm convinced, right? I think one of the things I kind of need to figure out is, and I think we need to figure out also better as an industry, is where there's this hook into existing standards. For example, the NIST CSF doesn't have a lot of it. The PCI has some of it. The BSIM and OpenSAM have some of this stuff, right? So it'd be quite cool to try to map which one of those, like which part of the policies and part of the requirements of those standards this does. Because I agree with you, like, the applications that don't do this, basically they don't have a good effective way to manage their permissions, and they will have issues caused by scaling. Because also on the other hand, we should have data to show that we're having a high degree of incidents caused by permissive mismanagement, which gets verified by real world exploits or security assessments, that the root cause sometimes is a lack of a permission framework.
Yes, yes. So I agree. I don't know how much it's already spread out within the industry. I think it's going to there, but it's not there yet. I think that all the big companies I mentioned, Netflix and Pinterest before, they are already doing something really, really similar, but this is internal.
Exactly.
And I think that we are at the edge over here trying to bring those best practices to the common users of everybody.
Yeah, and it's cool because the base is open source, right? It's the Opal stuff is open source, which is the way that you can get scalability. Very cool.
Yes, definitely. Most of the technology we showed you, it's open source. The only not open source is Permit, which also has a really generous free tier. And you can do everything we do in Permit with open source tools that we just showed you. So
no, it's really, really, really cool. No, great work, and great to have you guys present here at the Open Security Summit. I don't think we have any questions on the chat, so I'll just stop the recording, and thanks you guys for participating.
Thank you.
Thank you.